Welcome. In this tutorial, we will build our own reg system. You will learn how to read PDF, chunk them, generate embeddings, and then how to store them in an actual vector database. Lastly, we will connect all these things together through a Groq API so that we can ask questions about our document in natural language. Let's dive in. Hi, welcome back to the video. In this video, we are building a reg pipeline. We will upload a PDF, generate embeddings, and then store them in qdrant vector database. Now make sure you have Docker installed. Once you have the Docker, run this command to pull the qdrant vector database image. Once you have downloaded the image, let's run a container from it. Let's verify if the container is running. The container is running. Now let's verify. If we run this, it is not working. Why? Because image is running inside this container. So it has no idea about our IP address. So we will expose it to our make IP address. So we run this command. And let's try again. The image is currently running. We can see the collections, consoles, tutorials, resets. Now we don't have any collections because we haven't created any. We will do this in the next step. In this step, we are going to define a vector store class so that we can make the communication between the qdrant vector server and our code. So for that, I will install the client. The client is already installed. Now I will create a new file. Name it vectorstore.py. Now I will import the qdrant-client so that we can make the communication. And I also want to import the methods that they provide to find the similarity and other parameters that are very helpful to create our first collection. Now if we go to their distance class, now if you see, they provide a bunch of methods to find similarity. For this particular video, we will use cosine. Now I will write the vector store class, define the constructor. Now to create a collection, we obviously need collection name. So we will pass a new argument, collection name, and this URL. Now this will tell where our server is currently running. So I will just copy it and paste it here. Now I have to define the dimension of our collection. So I will say vector size 384. We will pass the default value. And now I have to define the method to find the cosine similarity. For that, we are going to use the cosine. Now let's write the body of this constructor. Now we have defined our constructor. Now let's see if is it working or not. As you can see, we have two collections already created. Now to verify if this client is working or not, let's write a dummy method. I will name it, is it working? Now we will write conditional statement here to check if the collection exists. If it exists, it will simply return true. And if it doesn't exist, it will return false. So our client is this self.client. So we will write self.qdrant-client. qdrant-client provides a built-in method, which is collection exist. Okay, this one. It will see if the collection exists or not. It's a built-in method that qdrant vector database provides. Now I will pass the collection name. If the collection name exists, we will return. Otherwise, we will just simply type. Now let's verify. We will create an object, name it obj vector store. Now we will write the collection name. Let's write PDFs. And now I will trigger this method. Is it working? Now let's print it. And let's see what happens. Okay. You can see it says it exists. And let's try with the other name. Maybe let's try Trump. Let's go with this one. Okay, perfect. So it says it is still not there. So our first step is done. Now let's write more methods to actually configure our collections. Since our client is working now, so we will write proper methods now. Now to avoid duplicate collection name, we will write ensure collection. It will check if the collection name exists, then it will simply ignore this method. Otherwise, it will create a new collection. If not, self.qdrant-client.collection exists. Now this line will check if the collection exists or not. If it doesn't exist, then we will simply create a new one. qdrant-client.create collection. Again, this method is built-in method in qdrant. Now this method will ask for two arguments, collection name and also the vector configuration. So let's write collection name. Now we will define the configuration of our vector params. Now this accept two arguments, size and distance. So we have already defined our vector size and we have already defined our distance. So we will write self.vector size and self.distance. To avoid bugs, let's write it in a proper way. Vector size and distance. Now this will check if the collection exists. If it exists, it will simply ignore it. Otherwise, create a new one. Let's write the else statement here. Now this will simply ignore it. Now let's write a method that will batch process our documents or text in the exact same format that the qdrant vector store expects. So let's write document method. It will take three arguments, text, vectors, and metadata. I'm using this metadata here because we also want to trace back where this chunk came from every time we retrieve something. Now, qdrant store data in the form of vectors in each collection name. That is why I'm defining this. Points list. Now I will loop through all of these data. For text, vectors, so you keep it vector, metadata, and because I want to run this loop parallelly so that we can feed this data into point system. That is why I'm using the zip method here. It will go through this text, vectors, metadatas. Now we will create a new point out of these data. So we will define a new variable, points, and let's import this method from qdrant. It's a point struct. Now this method will create a point for us each time. This point struct. Now this takes three arguments as well. It takes ID, vector, and the payload. The payload will hold the text and the metadata here. So let's import one more thing. Import. Okay. For ID, let's use UID for .hex. For the vector, let's store vector, and payload will store, or it will store the dictionary. Text is equal to text, and it will also store the metadata. Now I am using these two asterisks because this will unwrap all the metadata and insert this inside this key value. Now let's append the points list. Points.append point. Now let's insert all of these points in our collection. So I will say self.qdrant-client.upsert. We use this method to store all points in the collection. It will accept two arguments, collection name and the points. Let's define the collection name. We will use the same collection name we are defining here, self.connection name. Oh, sorry, it's not connection, it is collection. And now we will pass our points to points. It is it. Now let's move to the next part, in which we will search the particular chunk. In our vector store class, let's define the last method that will search for points in the collection name. I will name it search cells. It will receive the query vector. We will convert our query in the form of vector. So we will define this as query vector, and we will also limit the chunks to 5. I will store the data in result variable self.qdrant-client. Now again, this is the built-in method that qdrant library provides. Query point, this will search the data for us. It takes these arguments, collection name, query. So let's define the collection name first. Self.collection name. And let's also define the query. The query will be query vector. We also want to limit the data to k, and we also want the metadata. For that we will use payload is equals to true. Now also return this result. Return result. That is it. Now we can move to the next section as well. Hi, so our vector store class is done. Now we will write a PDF loader file so that we can load our PDF and then divide it into chunks and then feed it into the vector store. As you can see, I have created this PDF folder. Inside this, I have this my resume. It has 2 pages. So now let's write a PDF loader file. I will import the library that will read our PDF. I will define the file path. Let's get it from here. Copy path. Now let's the PDF loader function. It will take one argument, the file path. And I will use this class to read our PDF. I will pass the file path here. Let's store it in this variable reader. And now let's quickly see what it returns. So I will return reader. Now let's see. Now I will store all the data inside this. And let's see what it returns. I will print the data here. Okay, so it is returning this object at this location. Now Python gave us a built-in method to actually see what methods and attributes are associated with this object. So I will write dir. Now this will return all the methods and attributes associated with this object. Okay, now let me actually print it in a nice way. So I will import pp print. This will print this output in a nice way. Okay. It has printed all the methods and attribute associated with this object. Now it will have one method, pages. Okay, this pages. This will return all pages inside this PDF. As you can see, I have two PDFs, so it will return two objects. So let me comment this out and we will print data.pages. Now this will print all the objects, or you can say pages, that are inside this PDF file. Okay, so it is currently returning two objects. So let's get this one for now. Okay, perfect. As you can see, it has returned this object at 0th index. This one. Now we will also print all the methods and attributes associated with this object right here, so that we can read the data. Now I will also apply this method here to print all the methods. Okay, let's print it in a nice way. Okay, now it will have one method. Let me see. Oh, perfect. So it has this method, extract text. So let's apply this to this object. Let me actually comment this out as well. So I will say page 01 pages, and let's get the page object at 0th index, and I will apply this extract text method. And let's print this and let's see what it returns. Oh, I forgot to enclose these parentheses. Now again, run it. Okay. So now it has returned all the text from the page 1. Okay. Now if we wanted to print all the text from page 2, only this certification start from certifications. Okay. So let's change this to index 1. Okay, perfect. So as you can see, it has returned this data from page number 2. Now, since we are done with the testing, I will create a new list pages to actually store the pages and the index, so that we can feed it into our vector store and then also organize our text. So I will run a simple loop. Let me actually print data.pages. Let me print this in front of you. Okay, now so now we have two objects because we have two pages. Now we will run loop through each page for index pages in enumerate reader.pages, because we want to loop through all the pages. That is why I have applied this method to this object, so that it can give us all of these objects. And now we will apply pages. Let's keep it page singular, because we are looping through each page. And now we will apply extract text. And now let's write a condition, because sometimes what happens is we have multiple pages, but some of the pages are very empty, so that we don't want to use these pages. If text, if any page have any text, we will simply append this to this list. Okay. We will append what? Page number, the index, and also the data. So for that, I will simply type this and this. Actually, it is this index. Okay, sorry. Now you have noticed that I have added this +1 because index start at 0. So So PDF page number don't start with 0. They always start with the 1. That is why I'm adding 1, because 0 plus 1 is 1. And then I will simply return pages. So now let's print this out and see what it returns. I will comment it out as well. Print data, because we have already initiated this loader here. So you will just print the data. Okay, so we have ran into this error. So let me see. Oh, forgot. Oh, sorry. I enclosed this in the parentheses. Now let's run it again. Okay, so I have run into this error. So it says it takes only one argument. So I also forgot to enclose this. Now again, let's run it. Okay, perfect. So the data is in a bad format. So I will print it. Okay, perfect. So as you can see, we have page number 1, page number 1, page number 2, and all of that data that are associated with these page numbers. Now we are done with the PDF loader. Now we will write the chunk method. So let's create a new function, chunks. Now it will take 3 arguments, text and the chunk size, how many words we want in each chunk. So we will say 200 and overlap. So how many words should overlap in each chunk? So we'll define 50. So once we load this PDF, the data will be in this format. Now we want each word as an element. To convert this, we will use a split method. So word is equals to text.split. Let me actually show you. I will create a new file, repl.py. Okay, so let's suppose we have this string, Samad Gilal Abdul, and I want to apply split method. And let's see what it returns. Okay, so you see it is returning a list with each word as a separate element. That is what we are doing here, so that we can count how many chunk size, how many words are in one chunk. Now I will create a chunk list to store all of the chunks. Now I will loop all of this text, and based on the chunk size, I will separate this text or chunk from the file and then store it in this chunk list. For that, I will run a loop. For I in range, I will start from 0. I will go up to the len of word, and I will skip chunk size minus overlap. So it will jump 150 words each time. Now I will create a folder, and I will apply this method to actually combine all of these words, 200 words, into one list. So I will start from the index I, and I will go up to I plus chunk size, 200 words. So that this will trim 200 words. Now I will append, let's keep it plural, chunks dot append. I will append the chunk, and now let's return chunks. Now let's see if our chunk system is working or not. So let's create a new file, name it sample text.py. I will say simple text. Let's print, okay. Okay, so now we have this long string. Now we will pass this string into our chunk system and let the chunk do the work. So I will say from sample text, import, what was the name? Sample text. Okay, let's turn this off for now. It is very annoying. And now I will pass, let's comment it out. Then let's initiate the chunks function. I will pass text into text, sample text. Okay, now let's print it and see what it happens. Okay, perfect. So it has returned this long list. And let's see how many chunks do we have. Okay, so we have 2 chunks. Okay, so it has returned 2 chunks. Perfect. So now let's move to the next file. Hi, so we have everything ready. We have our embedding class, we have our PDF loader, and we have our vector store. Now I will define our ingest.py file so that it can ingest everything together into our vector store. So I will create a new file, ingest.py. I will define the function. It will receive 3 arguments, the PDF path, because we want to process PDF. We also want to store this PDF into our vector store. So I will import vector. And I also want to create embeddings. So I will import embedding or initiate this argument here. To actually process PDF, let me import the method that we just created. I will pass a PDF here. Sorry, PDF path. And I will store the data inside this, and let's simply return it so that we can test it. I will initialize the PDF path first. I will copy the path from here. Okay, to avoid any bugs, let's just keep it none for now, because now I only want to process this PDF. I will initiate the function here, pass PDF path to PDF path. I will store the data here. And let's print the data and see what it returns. Okay, perfect. So it is returning a list with tuples, the page number, and the text that it contains. So let's print it so we can see clearly. Okay, perfect. Now let's print it. Okay, so we have 2 tuples inside this list. Now the data is in tuple inside this list. So let's format it first. So what I'm going to do is I will create a list which contains all the text. And I will also create a new list, all metadata, to contain all metadata. It will contain this page number. Now I will loop through each tuple. For that, I will say for index page number, it will hold this page number, and text, it will hold this text in each tuple, and data. Now, since we have our text, I will convert it into the chunks. So I will say chunk. I will pass the text here. I forgot to import the chunk from PDF file. Chunks, it is actually chunks. Now, once we apply the chunk text here, it will also give us list. So we also have to loop through it. So we will say index and text chunk. So now this loop will loop through each page, and this loop will loop through all the chunks in that page specifically. I am very bad at naming, so let's keep it plural, and let's make it chunk. Now I will append all the chunks in that text format in the text list. So I will say all text dot append I will append the chunk. And I will also append this metadata. So I will create a list. I will say source, where this data came from. So it is coming from this PDF path. I will say page number. It is coming from this page number right there. And index, I will say index. And the reason why I'm appending these two lists together in parallel, because if we wanted to retrieve the metadata and also the text, we will simply do this all text 0. It will give the text at 0th index, and it will, and if we use this, it will also give the metadata that is relevant to this. That is why I'm running these two append parallelly. And now let's fill our other arguments as well. Sorry, this one is not vector. It is actually store. And now let's convert our old text into vector format. I will store these in vector variable because we will pass this vector in a store class. I will use embedding class. I will use encode method from it, and I will pass all text. Do not worry about this thing right here, because when we pass this embedding class here, it will trigger this class and this method as well. That is why I'm using this embedding.encode. Now let's trigger the store so that it can create a document for us. So I will say add document. And because I will pass the class vector store, this one here when I initiate the main class, and I will trigger this add document, and it will receive 3 arguments: text, vectors, and metadata. So I will pass all these things together. So I will pass all text, vector, and all metadata. Yeah, that's the format. And that is why, because this data will be written in the list format, smaller chunks, that is why we used loop here to loop through each chunk and each metadata index, and then each it will fill up these points. That is why we used this loop. And let's return something. So I will return all the chunks that it persists. Now that is it. Now in the next step, we will write llm.py file so that we can ask question in natural language. For this tutorial, you will need the Groq API key so that we can make the communication between our application and the LLM models that they provide for free. I will put the link in the description. Copy this, create a new file .env, move it out of the folders, and put it like this. Now create a new file. I will name it llm.py. Now import few things. We will import operating system. We will import and we will also import the Groq client. Now we will initiate the client. Before that, let's load all the .envs. Okay, this file will load all the envs in this file. Let's create a Groq client. It will receive API key. So I will say environ and Groq API key. Now I will create a function so that we can make a communication. So I'll say ask LLM. It will receive 2 arguments, the question and the context. Now copy this string right here. Let me explain it what it does. So every time when we hit the ask LLM API from FastAPI, so it will receive these 2 arguments, the question and context. So all of these will be passed here. The question will be passed here and this, and context will be passed here like this. And now we can send this to our LLM so that LLM can answer this. Now I will send this data to client, the Groq API, client.chat.completions.create. It will receive 3 arguments. The model that we are going to use. The model that I'm going to use is this Olama. Now I will pass this message in the form of list. So I will say role. Who is going to send this message? The user is going to send message. And the context will be this whole prompt with these variables. It is actually content, not context. And the last argument, that is going to be temperature. How much creativity you want from the LLM model. Okay, that is it. Now store all the response from this Groq API in response variable and just simply return response dot choices message dot content. It is actually response, not other thing. Now that is it. Now we will move to the next step. Okay, so this is our last step in which we will build our APIs and then connect everything together. Before recording this tutorial, I was testing it with my own code. So I found few bugs in our previous code base. So let's fix this. Go to vector store, return this instead of just simple result. Okay. Go to LLM, change message to messages. Also go to ingest.py, change this to text chunks because it was creating a conflict because of names. Text chunks. Now go to vector store, change this to this, and now we are good to go. So I have my Docker running right now, this thing. Now let's test if our vector store is running. Collections. Now initiate our vector store. So I will say vector store. I will give it a name, collection name. Let's give it a unique name. Let's give it a name Donald Trump. I will also initiate my embedding class so that we can create the embeddings. Now we will write our first endpoint in which we will upload our PDF and create a new collection. I will give it a file path. And I will use this method, ingest. It will receive a PDF file, so I will give it a file path. Now ingest.py receive 2 arguments as well, store and embedding, so that it can use embedding to create embeddings and store to actually store the data into that particular vector store that we have just created, Donald Trump. Okay, so I will pass store is equals to store and embedding is equals to embed. And let's give it a proper name here, PDF paths. That is it. And now ingest.py return all text, the count, so that let's store this here in this variable. Now let's check if it's working or not. So we will return a response. Response. Okay. We will also return count. And we will also return the PDF path as a source. Now I was also running into issue because of this file path name. Let's give it a proper name, remove hyphens and convert it into underscore. And then let's now create a terminal. Let's move to vector. Now we can simply run our FastAPI using this. Our FastAPI is running. Let's copy this. We don't have any collection with the name Trump. Okay, so we have our PDF here, PDF endpoint. Let's copy this PDF path. Paste it here. So it says, okay, number of counts 4 and the source. So our first endpoint is working. Now let's test if it has stored the data in the vector store or not. As you can see, it has created a vector collection with the name Donald Trump. Let's go inside it and perfect. It is currently working. Now let's write another API to actually search for our data. This one is actually simple. We will say app.get. I will say PDF search. We are going to name it PDF search vector. It is going to receive the query, the limit, because we want to limit a number of chunks only. We don't want the whole document. So I will limit, here we go, 5. Now I will convert my query into vector so that our vector store can understand it. Query vector. I will use this embed encode and I will pass the query. To actually avoid any bugs, let's wrap it inside this list. Now let's return the query. We are going to use store.search. We will pass query vector. This query vector and limit. And what is the other thing? I think it is, okay. So our another endpoint is working, this one. Let me try it out in front of you. I will say who is Abdul Samad Klal and I execute it. And it is currently returning all the chunks with the ID, version, and also the text that is relevant to our query. Now let's write our last endpoint in which we will communicate in the natural language. I will give it a name, ask LM Groq. It will receive the query and the limit int 5. Sorry, it is not int, it is a string. I will convert my query into query vector. So I will say embedded encode q. Now I will search for the relevant chunks. So I will use the store search query vector is query vector, this one, and I will limit it to limit. Perfect. Now we will store it in a variable so that we can always use it. So I will say matches. And now I will combine all of the chunks into one variable. So for that, I will use this method to, to create a new list, but with separate these out with these two lines. I'll create a new list, m.payload text, because our data is going to be saved in the text field right here. And we will loop through each chunk. Now we will also store this in this context. And now I will trigger this ask LLM. What is going to receive? It is going to receive question in the context. The question will be Q, and the context will be context. Now I will also store the response coming from this method. So I will say LLM response. And now I will simply return this response. Okay. And I will say LLM result. And I will say LLM response. Perfect. Now let's try it out if it's working or not. Also, we are running into this bug before we even started. Okay. And now I can see another issue. Let's wrap this out. And now I think we are good to go. Okay, so our ask LLM is here. Let's tell me something about Abdul Samad Gilal. I will just say 1. Okay, so it says okay, and the LLM has returned the response in human readable form. Now that is it. I hope you enjoyed it, and in the next step, we will build UI on top of it. Thank you very much.